Hey everyone, welcome to the tail end of our course. Now we're going to move on from quadratic expressions, these quadratic trinomials we've been doing in the last few videos, and move on to a couple of videos on algebraic fractions and working with these. So we're going to split this up into 3 videos, and we're starting with the idea of simplifying algebraic fractions. Now the most important thing to note about all of the algebraic fractions we're doing is these algebraic pronumerals are really just placeholders for unknown real numbers. So anything we've already learnt about equivalent fractions, simplifying fractions, adding, subtracting, multiplying, dividing fractions, they are going to still be true even when we apply algebra to this. That is the most important thing. Although it looks scarier, it is in essence the same thing. Now, we're going to start off by looking at a quick video on simplification. So let's think back to when we would simplify fractions back in year 7. What we do here is I have this 6/9 fraction here, 6/9, and what we wanted to do was we wanted to find a common factor, a number that goes into both top and bottom here. It goes into both the numerator and the denominator. And what we did here is we'd say, well, cool, I know that 3 goes into both 6 and 9. So I'd say, for example, 6 we can make into 3 times 2. 9 we can make into 3 times 3. Now, with simplification, with fractions, the top and bottom, if we have the same products on the top and bottom, they can cancel each other out. So this 3 and this 3 cancel each other out. Well, why is that? Well, this is because this is like saying 3/3 times 2/3. But this 3/3, anytime I divide a number by itself, that just becomes 1. So that is like saying 1 times 2/3, but 1 times any number or fraction just gives us back that number or fraction. So that's why our answer can get simplified to 2/3. And the shorthand way of doing this, the quick way, is to draw these lines through, to think of simplifying these by crossing off top and bottom. If we have the same products on top and bottom, those cancel each other out. The reason why is they cancel each other out to 1. So let's apply this to actual algebraic fractions. And we're going to do about 4 questions on this to give you a lot of practice with stuff like this. Now, as I've said before, it looks scarier, but it's really the same thing as what we've been doing up until now as it relates to fractions. Okay, so I have this fraction here. Now, all we're trying to do here is find things top and bottom that cancel each other out. Now, let me start with these nice numbers first. I can see that 3 and 6, the number 3 goes into both of those. So 3 goes into this numerator 1 time and into this denominator 2 times. So I can rewrite that as either 1 outside of x plus 2 brackets then x minus 4, but multiplying this 1 here is just the same as having this expression as it is. The 1 doesn't add anything, so we can just leave it like this. Oops, that's meant to be x plus 2. And here we have 2 outside of x minus 4. Now here, what's important to note now is that yes, we're working with these binomials. We're working with these types of algebraic expressions. But the most important thing to note is that all of these x's are the same number. When we assign the same pronumeral multiple times, that implies the number is the same. We would need a different pronumeral to describe a different number. So here, what this is essentially saying is some number plus 2 times some number minus 4, that same number minus 4, as a fraction over 2 outside of the same number minus 4. Even though we don't know what this number is, we know that this entire expression up here, x minus 4, is the same as this one down here. Because if the x's are the same, x minus 4, top and bottom, means the same number. So those are going to get cancelled out. And I'm going to do that by drawing this line through. So the x minus 4 on the numerator and on the denominator cancel each other out. And what we get left with is x plus 2 on the numerator over 2. And this is as far as we can go. So our answer in the simplest form is x plus 2 over 2. Okay, so let's move on. We have here 20 minus 5x as a fraction of 8 minus 2x. Okay, so here, there's not a lot we can do just yet to simplify it, because we need these products, this idea of these numbers timesing by each other on top and bottom, before we can start cancelling things out. We can't just start, crossing off this, then this, and go one by one. We need to now factorize. So that's going to give us any products that are multiplying with other expressions, so that top and bottom we can just cross off. So on this numerator, I'm trying to factorize. So I'm trying to find a number that goes into both 20 and negative 5x. One that I can think of is just the number 5. So 5 goes into 20 4 times, and 5 goes into 5x, or negative 5x, negative x times. And we're going to do a similar thing on the bottom. We're trying to figure out what goes into both 8 and negative 2x. Well, the only number that does is going to be 2. Now 2 goes into 8 4 times. 2 goes into negative 2x, negative x times. So now by factorizing, we can see that we have this 5 times 4 minus x, and on the bottom 2 times 4 minus x. Now that we have these products here, we can simplify top and bottom. Because this is like saying 5 on 2, let's write another line here. That's like saying 5 on 2 multiplied by 4 minus x on 4 minus x. And this thing on the right hand side is going to simplify to 1. Because I'm dividing a number by itself. That will always simplify to 1. So this is now like saying 5 on 2 times 1, or just 5 on 2. And that is our answer in its simplest form. By doing what we've learned about factorizing, we can break this up into separate products. And in doing that, we can see we have algebraic terms top and bottom. These will cancel out. Okay, so let's move on to the third question here. We have x squared minus 4 on top of x plus 2. Now, we can see we have a special type of quadratic on the numerator. This is, if you can see here, hopefully, I have x squared minus 4. Now, both of these values, both x squared and 4, these are perfect squares. And there is a difference we're subtracting between these perfect squares. So if we remember from our factorizing perfect squares video, I can write this as a binomial product. And both of the terms here are going to be the square roots of my two squares. So I have x and I have 2. And remember, the signs have to be opposite. One has to be positive, one has to be negative. So those middle terms end up canceling each other out. If you need a bit more revision on this, I have a previous video in the series that you can look at. I'm just working through it a bit quicker because I assume that if you've gotten up to here, you understand how to factorize this kind of stuff already. So I'm working a bit faster. So this x plus 2 on the bottom stays. And now we just want to see, do we have any similarities top and bottom? And we can see we have an x plus 2 here and an x plus 2 down here. These are going to cancel each other out, leaving us with x minus 2 over 1, because these just cancel out to 1. But anytime I divide a number by 1, that just gives us the number itself. So our answer here is x minus 2. All right, one more. This one's going to be a little bit trickier. It's going to require a bit more work. But for question 4, we want to simplify this. Okay, so as we sort of talked about before, we have these quadratics as we do on this numerator, and we want to see if we can break this up into some kind of product, because that's going to allow us to make these algebraic these fractional cancellations. So we need, anytime we want to simplify some algebraic fractions, we want to get everything into a factorized form. So both of these, whether we have expanded form or factorized, they are useful for different things. So in this case, for example, it is useful to factorize. So I'm going to have a little aside thing down the bottom in which I want to factorize x squared minus x minus 20. So in doing that, I'm going to write down my product, my sum, and then come up with the factors. So my product is going to be negative 20, my sum is negative 1, and I want to find my factors. So I want to find two numbers that multiply to give me negative 20 and add to give me negative 1. So if I want to pick out the factors of negative 20, it's important here, because this is negative, the combinations of factors we have is going to be one that's positive, one that's negative, and vice versa. But here we have a sum that is negative. So the number with the bigger magnitude is likely going to be the negative number. But let's just write out all the options and check. So we have negative 20, positive 1, or negative 1, positive 20, negative 10, positive 2, or negative 2, positive 10. And we also have negative 5, positive 4, or positive 5, negative 4. Okay, so let's start crossing off the ones that we can't use. These two up here we obviously can't use because we're going to have there's a pretty big difference between the two numbers. So I have minus 19 and minus 21. Those are clearly too big. Same with these ones. That gives us negative 8 and negative 12. It's going to be one of the two final options. Now, if I take 5 being the positive number and subtract 4 from it, I get positive 1. So it's not going to be that. And this is where I was saying the number with the bigger magnitude, so the 5, should be the negative, because we are expecting a negative in the sum. So this is the factor we go with. Those are the factors we go with. So here I have negative 5 and positive 4. Now, if I factorize this, I'll work through this a little bit quicker because I'm hoping everyone's watched the other videos. We should know how to factorize these monic trinomials by now. So let's work through this a bit quicker. We'll go x squared minus 5x plus 4x is it minus 20. This is the common factor when we group in pairs. This is our first pair. The common factor is x. I take that out. We have x minus 5 plus, and in my other pair, my 4 is my common factor, so I have x minus 20. And, whoops, x minus 5. My bad. And the x minus 5 now is a common factor for both of these expressions. So I can pull that out the front. I have x minus 5 outside of x plus 4. That is my factorized version of x squared minus x minus 20. So I can put my factorized form in place of this because it's the exact same thing, just written slightly differently, written in a different form. So we have x minus 5, x plus 4 on top of x minus 5. Okay, so now I can clearly see I have an x minus 5 both on the top and bottom. These will cancel each other out, leaving me with x plus 4. That is the algebraic fraction in the simplest form. Now you can see here with everything we've learnt about factorization, it can be pretty powerful for these types of simplifications because we've reduced something seemingly complex into something very, very simple, just x plus 4. This is how we can think about using what we've learnt so far about factorizing, about quadratic trinomials, all of the things previously in this video series, and we can apply this to now simplifying some trickier algebraic fractions. Thank you so much for joining me today. I'll see you in the next one.